Okay, my name is Xian Jiang from Department of Cell Biology. Thank you very much, Dr. Bob Wang, invited me to give a talk here. Actually, I graduated from Downstate Medical Center. My mentor was Dr. Mimi Haben. I still remember the time that I got my PhD and spent a night in the room, a small room, for the electrophysiology experiment. So my thesis still have a picture for that. But unfortunately, after I got my PhD, then I worked in the Columbia University for more than 10 years. And then 20 years ago, so I came back. But my research interest is not brain science anymore, the neurosciences anymore. So my research interest actually is lipid in the circulation or lipid on the plasma membrane. Okay, very obviously, cholesterol is the major one. But unfortunately, so many good scientists in this field, there's no room for us. So I'm interested in called phospholipid. Okay, one of the phospholipid called sphingomyelin. Everybody kind of familiar with that because it's enriched in the brain. Unfortunately, I'm not doing anything on brain. I only interested in the liver, adipose tissues, macrophage, and small intestine. So while I'm here, I only allowed for 4 slides. In the last slides, we'll have the rationale for my talk here. So more than 20 years ago, people noticed that in the tissue, there is a specific phospholipase called phospholipase C. But the phenomenon is there, the biochemistry is there, but who is the guy doing this job? Don't know until very recently. Because we are interested in the phospholipid, one of that is sphingomyelin. Actually, in the Jiang family, there are 3 members. SMS1, sphingomyelin synthase 1, 2, and SMSR-related protein, SMSR. So what they do actually is, first, PC, finally, is SM, and they can, in the middle of that, they can produce DAG, diacylglycerol, and a cellular can involve that, and finally form a sphingomyelin. SMS1, SMS2 can do that. But SMSR cannot do the sphingomyelin biosynthesis, but it can do a similar reaction, form a ceramide phosphoisolamine, CPE. So when we study that, so we realized that this particular family, we call the sphingomyelin synthase family, can do 2 jobs. First, they can hydrolyze PC or hydrolyze PE. And the second step is formation of SM and CPE. If this is true or not, actually we published that. We indicate that SMS1 and SMS2 is a specific PC PLC. So we are the first discoverer for this particular enzyme. And also we found that SMSR actually is a PE PLC. So today I just give you a small talk based on part of my PhD student thesis. So the first one is, how do you know that SMSR actually the PE PLC will purify the protein? Okay, and then we set up a study and indicate that this guy really is a PE specific PLC. And then if this is the case, then it should be regulate the PE levels if we get rid of that. Okay, and then the DAG should be increased also. So indeed, so in the real experiment, we could see that the PE PLC, the SMSR really can influence the PE in the circulation, in the tissue also, and also can increase the diacylglycerol in the tissue, also in the plasma. So why it's important? Because we stand in the liver, because I'm interested in the liver. This is normal mouse, the single knockout, the SM2 knockout mouse, the double knockout, 1 and 2 knockout, and triple knockout. And then we can see very obvious, the double knockout has a very high inflammation, 1. 2, have a high problem for the fibrosis. And the triple knockout can almost recover the phenotypic effect from double knockout. And also withstanding the cells, indeed, the triple knockout can correct a little bit the abnormality from the double knockout. And also we check the cancer, the tumor, not cancer. So double knockout has cancer, but triple knockout without cancer. So why like that? And then we set up RNA-seq and indicate that the triple knockout compared to wild type, compared to double knockout, has a lot of inflammatory regulated gene is downregulated. In other words, SMSR has something to do with anti-inflammation. And also we kind of test that whether this RNA-seq is real or not. Indeed, we found something interesting is very interesting couple of factors. One called the TGF-beta, which is involved in the liver fibrosis. And also we found that the collagen 1 alpha 1, which is involved in the liver fibrosis, reduced greatly in the triple knockout compared with the double knockout. So maybe you're not interested in that because you're interested in the brain. So why I'm here? So this is the final one. The rationale for I'm giving talk here is phospholipid are important lipid component in the brain and should be important in the brain health. Although our research focuses on phospholipid in the cardiovascular disease, we would like to collaborate with any colleagues here because we have at least 10 different kind of knockout in a transgenic mouse, single knockout, double knockout, triple knockout. If any of you are really interested in doing brain research, they are ready. I'm stop here. Thank you.